So I'm here to talk about data in the cloud, and I've been thinking about this and come to the realization that now as stuff is moving into the cloud, we used to run MySQL on the web and on the internet. That was the main driver of MySQL's enormous growth, and the LAMP stack was the propellant that made it so huge. Well, today I'm starting to think that maybe we don't have a stack anymore. Maybe it isn't a stack with software layered on top of each other, but it's a collection. It's an ensemble, and software is working together in a different way. And I think it is radically changing the way we develop software, use software, distribute software, and in many cases we don't even distribute software anymore. And so I'm here to talk about those changes as we see them and what we think is happening here. So a little bit of an historic overview. The software world always has had waves that come as S-curves. There's initially overexcitement, then it goes away, and then the real growth starts. And many of us got into the software business in the client-server era, the time when we suddenly realized that we need to divide applications into clients and servers. Everybody was a fan of Microsoft. All developers used Microsoft tools. And then suddenly the internet came along, and it disrupted the whole old paradigm. And that's when MySQL took off. MySQL was designed for being used by the internet. And that's how the LAMP stack grew. And the interesting thing here is that when you look at these trends, they may look like orderly and well-behaved shifts and transitions from one generation to another. But nearly at every stage, we've seen a 10x growth in user base. So back in the 80s, there were no internet users. And when MySQL was first created, maybe there was 1 million of them, maybe 10 million. But today we have billions of people on the internet, and these demographics drive the needs for new technology. So the LAMP stack has been a fantastic construct and a fantastic concept in the software space. It helped Red Hat grow, it helped JBoss grow, although JBoss technically wasn't part of the LAMP stack, and MySQL, of course. And I think today, the LAMP stack is stronger than ever before, and people say that MySQL 5.5 is the best MySQL ever created. And at the same time, just when we are at our strongest, that's also when new shifts start to happen. And now we're moving into a cloud environment where the whole past stack is being challenged and disrupted, and we are seeing new technologies come in. And not that the old technologies would go away, which they rarely do. They stay there. But we see it today with the amazing number of forks and branches of MySQL and storage engines and main memory layers and handler sockets and all kinds of things just around MySQL. And then there's a bunch of other products that are coming up there. Because during the last 10 years of the LAMP stack, this didn't happen. In the database space, we didn't see new technologies. There were attempts at object-oriented databases and XML databases and all kinds of things, but they went nowhere because the LAMP paradigm was so powerful. But today, with 10 times more people on the internet, 10 times more connected devices, if not 100 times more, we have new demands, and suddenly we sit here in a cloud deployment with MySQL and MongoDB and Sphinx all in the same application. So in these times, when I was CEO of MySQL, we were a disruptor of the market. So we're a little bit afraid that somebody thought that we should be caught dead or alive. And we had our scenario planning and thinking what the worst thing is that could happen. Well, what turned out to be the case was, however, that the world wanted us alive and kicking, and there was a big price tag for this. And you may not know it, but Oracle came to us for the first time in November of 2005. So 5 years ago, for the first time, they said, MySQL, we would love to acquire you. And already at that time, we had major shareholders who were ready to sell to Oracle. But others weren't ready, and we thought we should develop the business, so we kept going. In 2008, we had this magnificent offer from Sun that we were entertaining, and there were, through all this time, other parties interested as well. And even as we were negotiating with Sun, Oracle kept coming back, calling me, saying, Marten, we will pay more. We had an exclusive agreement with Sun at the time, so we couldn't entertain them, but that's the huge excitement that was around the product. And we can wonder why this happened. What's the secret of success? Was it the fantastic product that Monty created in the 90s? Was it the amazing team of 450 people who built the business in the 2000s? Was it the LAMP stack, or was it the internet? What was it that drove this amazing growth story and just an amazing disruption of the market? And I guess the answer is that it was all of the above. It takes many different components to create a huge success. And so it's not possible to find a single cause for it or a single reason. The great thing now for me to look back is to see that the MySQL ecosystem is doing so well, that the MySQL product developed by and produced by Oracle is so strong, and that MySQL is all over the place. Amazon RDS, that's MySQL. Google is offering MySQL as a hosted service. Google is running on MySQL. Facebook runs on MySQL. And how many times did Facebook come to us and say, your database doesn't scale anymore, we need to move away? They did, because they had these 10x growths. But every time we figured out something, and MySQL is still there and a key component of the Facebook infrastructure, which is becoming one of the most massive software applications in history. So this has big implications on open source as well, on free and open source software. So 10 years ago, when I joined MySQL and I was a newcomer to open source was a disruptive movement. You were brave if you entered it. And it was driven by innovative growth companies. There was JBoss, there was MySQL, there was Sleepycat. There were all these companies who were driving this. And Fortune magazine did an article about the disruptors of Microsoft and how Firefox and MySQL and Linux were attacking the fortress of Microsoft. And it was really a big disruptive force that expanded very, very rapidly. And the software model was distribution-centric. All we talked about was downloads, distributions, in what distribution are you, how do you download, how do you install. And it was enabled by the internet, because before the internet era, software was bound to channels that were controlled by big companies. But the internet was like a freeway where anybody could drive, and anybody could drive free of charge and drive fast. But today, open source is established. Open source has won, and it's now an established practice, and it's mostly led by large corporations. Most open source contributions are from people who work for large corporations. Eclipse is a large corporation gathering. The Linux Foundation gets its money from large corporations. Oracle is probably the biggest vendor of open source now with MySQL and Java and Glassfish and other products. Microsoft is a producer of open source. So all these innovative growth companies, the challengers, the big, the bold companies, they are now acquired or part of something bigger. Not all. There are still some brave ones out there. The Mozilla Foundation is probably the best example of a completely independent, well-funded entity. And the software model has become service-centric. So it's not about downloads anymore. It's not about distribution so much. And this changes the logic of open source, because the most successful open source license or free and open source license so far is the GPL license, which is based on copyleft and talks about distribution of derivative works. Well, derivative works still exist, but few people distribute them. So the dynamics of this is changing, which means that you could say that cloud computing is challenging open source. You can have companies modify and fork your product and never release the changes because they are not distributing. So open source really is being redefined by cloud computing, and it's a positive and a negative. The positive is that everything in cloud computing is open source. You have open source all the way up on the connected devices in Android. Let's hope it stays open source. And you have open source down in the infrastructure with Linux, with KVM, with the open source platforms. But the nature is changing, and the nature of development is changing, and the nature of contributions and distributions is changing. Did I click? I should click. There we go. So when it comes to databases, I see a similar shift there. So again, it's on a time scale here, where on the left you have the relational databases that grew up in the 80s and the 90s. And we had Informix, Ingress, Sybase, DB2, Oracle, SQL Server came after a while. And they built a huge business. And there were 0% of the world population in the internet at that point in time. And they perfected the relational model, the SQL language, and everything. Amazing businesses. And they mostly were scale-up oriented, meaning if you had a bigger database, you bought bigger iron, and that's how you got more power and more room for more data. And that was okay, because we're not internet age, and we didn't walk around with petabytes on our flash drives, because there were no flash drives. And then came the next wave, the scale-out relational databases, which is nearly 80 to 90% MySQL. And I'm painting it here as a bigger circle, not because there was more money there, which there wasn't, so that we know. But in terms of installed base, the new era took completely over the old one. And that's what we lived in the last 10, 15 years. An amazing expansion of databases where suddenly it was scale out that was the real thing. MySQL that never could scale up had to scale out, and suddenly we realized that scale out was the way to go. And now, as we have come to a point where 30% of the world population is online, and the world population has grown by 1 billion in this time as well, we have so much people, so many connected devices, so much data, and so much demand on IT. A human being uses much more software or much more applications today, a much longer time of his day than previously. So the demands are so enormous that even the fantastic LAMP platform isn't enough anymore. And we see this huge splintering of the world, and we talk about NoSQL, we talk about new SQL, we talk about post-relational, and we're a little bit confused. It used to be so easy. You took a LAMP stack and you were done. Like Mark Zuckerberg says in the Social Network movie. I think that's the best quote when he says, "I need a MySQL backend." That was so obvious for him, but today, if he would start, what backend would you use? MySQL is the dominant one, the strongest one, the best one, or should you do it with MongoDB, or Cassandra, or a mixture, or Sphinx if you do full-text search, or do you need to go Hadoop because you have so much data, or do you need to combine Hadoop with something else? And suddenly we stand in a place where there's so much happening that we have many new paradigms coming, and we don't know which one will be the dominant one, or whether there will be multiple dominant designs. So far, we haven't been able to afford it, meaning object-oriented databases just didn't have critical mass. But perhaps now there will be critical mass for more than one category. And you are as good judges of that as anybody in knowing what it is that we really need. But we do see today how we are breaking down the stack, and we are coming into a collection of software where you have multiple products working side by side, and you can even turn the stack upside down. You don't just have a database running on a file system, you can build a file system on a database. So it's interesting to see where this is taking us, and the driving force is the logarithmic, or exponential growth in usage. The fact that we have so many more people on the internet today than we had just 5 or 10 years ago. And this changes the situation completely for everybody here. Not that the LAMP stack would go away. I think it will continue to be a fantastic business and ecosystem for the next 10 years. But the new stuff will be built just like we'll build on the new technologies. Just like Yahoo in, I think, 1999 started working on MySQL. Google started using MySQL in the early 2000s. Then we had Facebook. They were brave companies to start using them back then. And similarly now, brave companies will pick new technologies to build the next generation. So here's just some names, and I've tried to collect all the names of all the NoSQL, new SQL databases, and pardon me if I left out anybody, because there's so many, and I'm very happy to see all of you, and I wish you all the success. I know that every single product here is 100 times faster than MySQL. Even MySQL is 100 times faster than MySQL. So, okay, so performance matters and will always matter. And then we have key value stores, and we have simple databases and complex databases, big data, small data, main memory data, auto-scaling, so many new concepts, and we don't know which one it is that will really be the dominant one, the driving one. What we do know is that some of the old strengths have become weaknesses. So in the old client-server time of relational databases, when Oracle and Microsoft and IBM's DB2 grew up, complexity was a benefit, and scale-up was a benefit. Those two are now weaknesses. To really scale out on planetary scale in a cloud, you must have simple products with simple protocols, simple APIs. so that you can massively scale out horizontally. And something that for MySQL was seen as a weakness, meaning its simplicity and its scale-out features, meaning replication initially, those have become strengths. And this is how technologies shift over time. So what do you do when you deploy data in the cloud? And here's a summary of input I've heard from many of you. I've reached out to some of you to ask, how do you do your deployments today? If you're really new, what's the recipe? And there is no clear recipe yet. There are many different products that we see out there. They are mixed and matched in many different ways. People use MySQL with Memcached, or they use MySQL with MongoDB, or they use add Sphinx if they need full-text search, and so on. But it's more and more that people separate the reads from the writes, which give them two different scalability avenues, and reads are easier to scale, so you can scale them through replication. Writes are more difficult to scale, but you can scale them through sharding and partitioning. All of these targeted at a cloud environment where you operate on small nodes that you spin up and spin down. So in a cloud environment, you don't play with the size, so much with the size of the virtual machine, but you spin up more and more of them to scale. And many are considering different database solutions in the same application to solve different things, because we are now smarter about it. The products are easier to use. We can handle the situation of 2 or 3 different products in the same system. We must plan for failures, because nodes go down and there might be latency problems. The network may go down, so we must plan for it. And when we plan for it, we can reach a high level of availability. And just think about Facebook again, how a system with 500 million consumers, or 500 million human beings using it, when you update your status, all your friends see it nearly immediately. How the heck do they do that? And they keep that information in a database, because when you come back a few months later, the information is still there exactly as you stored it. But as you're updating it, it is sent all over the world to wherever you have your friends, and they see it, and they see a collection of it. So we each have individual home pages on Facebook. So they maintain 500 million people with 500 million home pages that are a collection of the data coming in and out in near real time. And all of that goes into a database and can be searched and used afterwards. That's amazing database functionality that we just didn't have before. So, and they do plan for those failures. You never see them. There's rarely any downtime on Facebook, and I'm sure they have nodes going down all the time. I do remember that Google told us that for their MySQL installations, they have a mean time between failure of 400 years for every MySQL server. I said, how can you know that? You're not that old. And of course, they have so many servers. So if one fails a week, they can estimate that on average, they fail every 400 years. But you need to plan for it. And you need to plan for 10x growth steps. So it's not like your data will double. Your data will grow 10 times or 100 times. And when you do that, you may need to re-architect what you have built. And then you can deploy it on a cloud service, a public one or a private one. And when you use a common abstraction layer, it means you can deploy it anywhere you like. Oops, sorry. Yeah, that was right. So here's a very schematic picture of the new world, where you don't really have a stack. You have a collection of services. If you go to Amazon Web Services, the absolutely most popular public cloud and the leader and the pioneer in this space, you know they have virtual machines, you know they have storage there, but you don't need to see it. So I've blended it out a little bit. You don't need to care about it, and actually you cannot care about it. If there are things you would really like to do with them, they don't allow you to. They give you a common API, they give you the EC2, EBS, and the S3 APIs, and that's it. And that's what you work with. If you use Eucalyptus on the private side, you have exactly the same APIs. So what runs on Amazon runs on Eucalyptus. What runs on Eucalyptus runs on Amazon. And then Eucalyptus runs on anything. And there you do get access to the underlying hardware, and you can configure it any way you like. So it gives you 2 different worlds. One where you get the convenience of an API, and that's all you need to do. You have unlimited scale globally, anywhere, anytime, and all you need is your mother's credit card, and you're ready to go. And then you have the private side, where you choose to be in control, to be within your own firewall, to configure your hardware and your machines and decide what you have there. But again, the applications need not know where we are because you have exactly the same API serving them, both on the private and on the public side, which of course allows you to build hybrid solutions where you develop on Eucalyptus and you go live on Amazon, or you run on Amazon, but you run the base load on Eucalyptus, or you have a hybrid solution where you run it on Eucalyptus and you burst out to Amazon when you need excess, when you have excess workload that your own capacity cannot handle. So with this new trend into cloud computing where, like I said, we see 10x increases in the number of people who are using the internet. We see 100x increase in the number of connected devices. We today have something like 6 billion connected devices in the world, 6 billion things connected to the internet. And people predict that we, in the next several years, will get to 1 trillion connected devices. The only way to serve that is through cloud computing infrastructure. Because these connected devices, whether they are gas meters or medical devices, or they are your iPads or Kindles or whatever, they have spiky workloads because they work when they need to work, and the rest of the time they're idle. So you can't have dedicated servers for them. You must have a cloud that serves whoever needs to be served at that moment. So that's why I believe that mobile is driving the growth of all of this and the change in software. And I also believe that the social aspect is doing it, funnily enough. And you could say, how does the social stuff really affect databases? We're deep in the infrastructure. We don't care what the application is. But it has been shown over and over again that demographics drive technological change. And the fact that so much, already 30% of the world population is online, and more are coming, that they will all have social needs. And I'm saying social in the broad sense. I'm not talking only about Facebook and LinkedIn. I mean, everything you do there, people are expecting to have real-time access to their information, real-time access to each other, real-time access between devices. And to keep such a fabric going, you must have a cloud platform where you can scale out without pre-planning, where you can scale out upon your need. And as I mentioned here, my second bullet point, the existing models for free and open source software are really undergoing change now. Most of the open source code today is produced by people working for large corporations. A lot of the code produced today is never distributed. There can be huge in the sense of hugely different forks of MySQL used all over the planet, and we will never know because those companies develop it for themselves and they never release it again. So it's changing the nature of free and open source software. And it's also changing the emphasis over from just code to API and data. And there are situations where we say, okay, I don't care if the code is open as long as there's an API so I can access it. Or some people say, I don't care if the code is open or the API is open as long as I can download my data and withdraw my own stuff. Just like in a bank, you put money in the bank because you know you can take it back. And that's why you also leave it there. If you ever doubted that you can take back withdraw your money from the bank, you would immediately withdraw it. And I think the same will apply to many areas of software where we'll say, I'm happy to keep my data there on Dropbox or Box.net or Facebook or anywhere, as long as I know I can bring it back to me whenever I need to. And maybe you never need to, but you need to know that you can. So openness is getting new meanings. It's not just the code, it's the APIs and the data. And we have to change our ways of working and the ways we create communities and the way we communicate in order to live up to these new demands. And then I do think that there will be a major reward for whoever creates the next big database, the next dominant design and leader in that space. I just don't know which one it is. I look at the products, and many of them come to me for advice or to discuss with me, and it's amazing stories that they tell me. 10x, 100x improvements in performance or scalability or latency and auto-scaling, and has none of the deficiencies of MySQL, but all of the benefits. Just amazing value propositions. And I can't know which one it is, but I'm sure that there now is room for new winners because the universe is expanding so rapidly, and it's much, much bigger. And we'll probably have a more varied landscape where it's not just the LAMP stack. And of course, the LAMP stack has many variations, but it still was the LAMP stack. I think we will have to get used to collections of software where we have different categories that win. And it will be very exciting to see that happen. So with that, I'll stop here. Thank you for inviting me. Thank you, Colin, and look forward to chatting with you in the break.